Hey y'all, welcome back to the Hack Shack. Today we've got another hacker box from Hackerboxes. This one is number 77, Veritas, and this one's a little bit older. It's been in my hoard of to-do kits and backlog of stuff for quite a while. As you can see here, I got this back around April of 2022 and just now getting a chance to do it. Also note there may be a lot of resources that you see me reference in this video, and I just want to let you know, even if I don't say it, all the links will be in the description. From the initial looking at things here, it looks like this kit is basically a DIY lie detector. The folks at Hackerboxes say this was inspired by the TOR DEFCON 29 badge, which was basically a mini lie detector. I'm excited to give this kit a go, so let's see what we've got here in the box. First, we've got our really nice PCB here. Next is our Arduino Zhao microcontroller. Then we've got two of those OLED I2C displays that we'll be using. And here are some micro switches, a socket, potentiometer, some rubber feet, and the LM324 quad op amp. Some Hackerbox branded Velcro cable ties. These are nice and handy. A USB-C cable for programming the microcontroller and providing power. This is the heart rate sensor module here. And these are the surface mount resistors and capacitors for the kit, as well as the clear sealing wafer. And this nice Hackerbox bite-sized sticker. And of course the always nice, colorful information card that comes in every kit. The first thing I'm going to do here is kind of get everything organized and get on my parts where I can see them so I can not have any trouble when I get ready to start assembly. I decided to do all the surface mount capacitors and resistors first, and did that by putting like the one little blob down on one side, holding with tweezers, and then doing the other side, and sometimes coming back and adding a little solder to the first side to make sure it was a good connection. Next, I did these little momentary switches. Then I soldered down the microcontroller after using some blue tack to kind of hold it in place for the initial solder points, and then rattled the rest of those off. A bit of cleaning here with alcohol and a toothbrush. I used a little mechanical persuasion to adjust the leads here on this potentiometer to get it to fit in the PCB okay. I had a bit of stray solder from the resistors that I had to clear out of that hole. Didn't quite get all of it. You'll see I end up applying a little bit of heat here to get that socket to go through all the way. Then a bit more soldering of the socket and the potentiometer. Here I'm jumping a connection on the back of one of these I2C OLED displays, and that's in order to give it a different address, because by default they all come with the same address, and if we don't change that address, there'll be a conflict on that common I2C bus. So that's why we're doing that, and it'll help us match the code that we're going to use later. Here I'm just mounting the displays and soldering them to the PCB. Snipping excess leads, and another round of cleanup. Here I'm putting the LM324 into the socket. And here's where I must apologize to you, the viewers. I made a big goof. I thought I was recording when I installed this pulse sensor here, but I was not. I basically cut the leads real close, stripped them off, soldered them as you can see there, put a little extra piece of wire around the other side, and soldered it down in place, followed by a quick cleanup. And then I applied the clear wafer to the front of the pulse sensor, but I probably should have waited on doing that, as we'll see later. And this is when I mounted the little rubber feet. At this point I was ready to get my Arduino environment in order to be able to push code to the Zhao microcontroller, so I needed to go check out the notes reference for the DEFCON TOR badge to look at the proper steps for doing that. And when I did that, I found the specific URL to point my environment to download the board options, as you see right here, and that let me pull those down, and from that I could make a selection and pick the Zhao board as one to use. After getting the board stuff situated, I started looking at the other dependencies that were needed for this code, for this project to work. I already had the SSOLED from previous project from Hackerbox, and so then I just needed to get the Sleepy Dog library as well as this Flash library. So I proceeded with getting those. Next I grabbed the TOR project code, then I saved it as a new file, and then I set my board to the proper Zhao board within Arduino. I then connected my board to the PC, and then I proceeded to push the code to the microcontroller. Here's the first boot of the device, and it looks like it's working. And please note that the instructions that Hackerbox gives you will tell you to do some testing before you solder your microcontroller down. I did not do that, but it's probably a good idea to do that so you don't go through all that trouble if you have an issue. I wanted to mention here, there's a note that says step 6 there, and it's mentioning that the pulse monitor has some issues. It basically boils down to things looking like the light's just too bright, so either people have put tape over the LED that emits the light, or they swap out this resistor as indicated to tone down the LED brightness. One of the suggested fixes to try was to put a few layers of painter's tape over the sensor to see if that worked, and that seemed to work pretty well for us and got the heart rate monitor working in a consistent manner. Now I'll give a look to the GSR meter on the left. Now pay attention to those values. I'm going to moisten my fingers and place them back down, and see that lowers that resistance, so that lowers that number, which would kind of go along with, the whole thing about the theory. If you're telling a lie, your heart rate may change and your GSR, your fingers may get more moist, and that would lower to be an indicator of perhaps a non-truth. Let's check out some of these other menu options. One here is, pretty self-explanatory. It lets you adjust the screen brightness. Nothing big deal there. The next one is this sleep mode, which could be handy if you were having this battery powered. You could kind of put it to sleep and then press another button to wake it back up. That could be handy if battery powered. There's an option here to calibrate the GSR. This cheat mode, I'll let you look that up. That's pretty funny if you want to mess with someone while using this. But I'll let you see what you think about that yourself. These bling options are pretty neat. One of them is a fake pulse, which should be kind of self-explanatory. It'll just sit there and do a fake heartbeat, that kind of thing. No big deal there. Kind of cool looking. This logo scroll option will scroll a TOR logo from left to right across both OLED screens. That's kind of neat. The bad DEFCON advice option has, a select number. I think, right here, like there's 45 bad advice things you can scroll through. I'm not sure if they'll rotate by themselves if you leave it alone. I didn't leave it idle that long with that on there, but that's kind of funny, in relation to tips for DEFCON that may not be so great. This option here is kind of cool. You can put in some text or whatever you want, and it'll scroll it on the displays. So I just stuck my name in here, and you can see it scroll. This last option, help, just shows where to get help and where the code came from, and contact info for the author of the program. And it also shows uptime here. With that, the project is pretty much complete and just needs to be, tinkered around with. I'm looking forward to messing with it. Hey, this is Jamie from the future, making a comment after the editing was underway for this video. One idea my young partner in crime and I had was to peel the tape off and maybe try a little dab of fingernail polish on the LED. So I gave that a shot, let it dry, tweaked it a little bit, but if you see here, it looks like it works like a champ, so that's an option for you if you ever use one of these sensors. This video is referenced a few times in some of the links and resources that'll be in the description, but I just wanted to make sure and show a little bit of it here and to mention it. It's very cool. The creator CS goes into some detail, more detail than I have, about some of the nuanced kind of things related to the project, so I think you might find that very interesting. Now, this particular kit is sold out, but don't let that dissuade you from going over and checking out Hackerboxes.com. They've got a ton of great stuff over there. See if anything strikes your fancy. If you really want to try to build something like this and you're bummed that the kit is no longer available, you know, it's not that big of a deal to maybe try to do it yourself. You can build this on perf board if you want to, and you could get, you know, normal through hole sized components to use for the capacitors and resistors. Potentiometers are not that hard to come by. Now, I've got links in here to Amazon for the microprocessor and an example pulse meter. Between those things and going by that schematic, you could probably throw something together that would work pretty well. Hey, if you made it this far, thanks for watching. Hope to see you again next time. Take care. Bye-bye.